and I'm not recording. So as you put them in, just be careful. Maybe go nice and slow or go back and check, whatever. See, I already made a mistake. I don't see many of y'all in here typing, which is kind of disheartening to me. Unless y'all are that fast. There. So there's, something's not right. That one should be way up there. Oh, because that should be at 11. See? There it is. All right. So here, I have my scatter plot graphed. Hopefully you do too, or at least you're very close to. Let's talk about the correlation that we see here. What kind of correlation do we have? Positive. Good. Yes, it is a positive correlation. Good. Yes, it is positive. Now, what we're going to do, though, is take it a step further and look at how positive. Sorry, that was a tongue twister for me for some reason. So we're actually going to use this handy-dandy tool to help us write an equation. So I always say that the calculator is only as smart as its user. So sometimes we will have to, know the process. It does not just type things in. So today we're going to write an equation. We want to use y1. And the reason we're using the 1 is from the table because we have to tell the calculator, which is Desmos, what we want to use. So we're going to do y1. And then I want to do the squiggly. Make sure everybody's at least finding that button right now. If you're not with me right now, then at least find that button. Find where you can see the squiggly. If you don't have it on your if you're on an iPad or something, you can find it by clicking the ABC button in the bottom left-hand corner. And then it's underneath the B. Even if you don't have an iPad, it'll work that way as well. Okay? And now we want this equation in mx plus b format, so I'm going to do mx, but I need to tell it 1 because I want it to use that column, and then plus b. So there is our information. So we can gather a couple of things from this. The first thing is the r. This value right here is 0.997. This is what we call the correlation coefficient. This value tells us how strong or how negative the correlation is. In this case, this would be a strong correlation. And it would be strong because of how close it is to 1. It's almost 1, right? The other thing we can actually do is write our equation because we have an m and a b. Now, it's always going to be some crazy decimal, but that's okay because we can round. And for the sake of today, we're going to round to the nearest tenth. So for y equals mx plus b, we have y equals 0.2x plus 0.1. So we were able to see two things here. We were able to write an equation, and then we were able to determine that this is a strong correlation. The value 24.2 represents a 7-month-old panda. Eventually, this equation, we can't use this equation because that means it can be further out, right? And it may not be the trend later on, so we have to consider that. All right, let's look at one more thing. It says here, in the following situations, there's likely is there likely to be a correlation? If so, does the correlation reflect a causal relationship? So we're going to explain these. The cost of a family's vacation and the size of their home, or house, it should say. Would there be a relationship between these things? I mean, would there be a correlation, I guess I should say?
No.
There shouldn't be, right? The cost of a vacation and the size of their home. So this would be no correlation. Okay? Because there's no correlation, it can't be a causal relationship. Because there's no relationship, essentially. It's all over the place. So one cannot cause the other to change. So what about the next one? The time spent exercising and the number of calories burned. Positive, yes. And we know it's positive because you spend more time exercising, you're going to hopefully burn more calories, right? But my next question is this a causal relationship? Does one cause the other to change? Yes. So then it would be a positive causal relationship. We could also talk about how strong it is and all that if we had more data, but we obviously don't have enough information here because everybody's different, right? Especially when it comes to those things. All right.